So I hope you remember from your GCSE days the word isomers. That's two or more molecules that have the same molecular formula, but when they're structural isomers, they'll have different structures. They will have different connectivity. They'll have different atoms bonded together. Now we're going to think about isomers for this movie because it's a really good way to practice our naming and also to think about how we talk about different organic compounds, how we visualize them and so forth. So let's start off with C4H10, which we know is butane, and we've seen it before. 1, 2, 3, 4 carbon atoms in a nice chain. Okay. Now, a lot of times you'll see this not just called butane, but you'll see it called N-butane, right? Normal butane. Now, that's one way in which we can put 4 carbon atoms and 10 hydrogen atoms together. But there's another way as well. Not using a 4 carbon chain, this is as good as it gets with a 4 carbon chain. But how about if we take a 3 carbon chain and then we put that 4th carbon bonded in the middle, like this one. There's 1, 2, 3, so that makes it a propane. And then we have this last carbon stuck off the 2nd carbon of the big chain, so it's a methyl group on the 2nd carbon. So this would be called 2-methyl propane. Now, until 1920s or so, nobody would ever have said 2-methyl propane, and indeed an allowed alternative name of it until 2010 was isobutane or I-butane, because it is an isomer of butane. Okay, so 2 isomers of C4H10. Now let's quickly think about what's your preferred way to draw molecules so that you can distinguish between these isomers, because this is already getting a little bit busy here, isn't it? Okay, that carbon sticking there with those 3 hydrogens on it. It's sort of tough for me to be able to draw those 3 hydrogens there so they don't bump into these. And that looks kind of ugly. I don't know about you, but that's also squished together and not very aesthetically pleasing. So a lot of times we're not going to use those full structures for this because it's too much detail. Right, you can't see the wood for the trees, so to speak. So we might want to think about drawing these in these condensed structural formulas. Okay, and that's not a bad way to do it. You can also, of course, use the skeletal ways to do it. And of course, the less of the confusing detail that you put out, the more obvious it becomes how these are different structures. So I will be using these most of the time for the rest of this talk, but if you're happier filling it out yourself like this, it would be good practice to help you see that. I would recommend you don't mess around with these full ones any more than you absolutely have to. Let's practice drawing these isomers. Let's skip C5 and move straight to C6. How many different ways, and I want you to pause the video and try it yourself, how many different ways can you think of putting together 6 carbon atoms and 14 hydrogen atoms to give you different structures? So pause the video and then come back. So I hope you're back. The way I approach this is I try to do it systematically and think of it in terms of let's do the longest chain and see what's left. So the longest chain can obviously be 6 carbon atoms. That would just be 6 in a row. That would give me hexane. How about if we have 5 carbon atoms as the longest chain in our molecule? Well, that will give us a pentane, but then there'll be a carbon atom left, which can be on as a branch or a methyl group, so methyl pentane. And we could put it on the first one for 1-methyl, the second one for 2-methyl, the third one for 3-methyl, the fourth for 4-methyl, the fifth for 5-methyl pentane, right? 5 different possible places to put it. Now, I trust you're all shaking your heads because, of course, there are different ways to draw the same molecule. 1-methyl pentane, if we look at this, has got just 1, 2, 3, 4, 5, 6 carbon atoms in a chain. It is the same as hexane. So I'll put it in a nice little red box because how I depicted hexane itself, but I'll cross them out because it's not an isomer, it's the same molecule. 2-methyl pentane, no problem, right? There's the methyl group on the 2nd carbon atom. By the way, if I did the chain 1, 2, 3, 4, 5, which is of course the intuitive way to do it, or whether I did it 1, 2, 3, 4, 5, there's still a 5 carbon chain. either way, the 6th carbon is off the 2nd carbon. All right, there it is there, 2-methyl. Or if I started here with 1, 1, 2, there it is still 2-methyl. 3-methyl pentane, so that's with that methyl group on the 3rd carbon. Doesn't matter whether you start numbering it from the left end or the right end, that is still the 3rd carbon. 4-methyl pentane, you'd say, okay, well, it's on the 4th one. But except, of course, if I start numbering here, then it becomes 1, 2-methyl pentane. So I'll put that little blue box just to indicate it's the same as the 2-methyl pentane, but I'll cross it out because it's not an isomer. And now 5-methyl pentane, well, 1, 2, 3, 4, 5, 6. That again is just a straight chain hexane. So put it in the red box and cross it out because it's not an isomer. So we have one isomer of C6H14 that has a 6-carbon chain, 2 isomers that have a 5-carbon chain. See if there are any with a 4-carbon chain. Well, if you've got a 4-carbon chain, then there must be 2 other carbon atoms that can be there as branches. Now, 2 carbon atoms could be 2 methyl groups, which I could put on the same carbon, so 2,2-dimethylbutane, or on different carbons, 2,3-dimethylbutane. And every other possible way of sticking in 2 methyl groups is going to generate one of the previous molecules we've seen. Or you might think, well, okay, I've got a 4-carbon chain, so that's a butane. I've got 2 carbons left. Maybe I could put those 2 carbons together as an ethyl. So that would be this, right? 1, 2, 3, 4. There's my butane, and there's my ethyl group, 2 carbons there. Now, can you see what one this is the same as? If I now, instead of say, here is my long chain, I start here and go 1, 2, 3, 4, 5. It's actually a pentane is my longest chain, and then the methyl group is off the 1, 2, 3 position. So I'll put a little green box about that because it's the same molecule as 3-methyl pentane, and I'll cross it out. So 5 isomers of C6H14. Okay, if you got any others, then see which of the ones that I've drawn here are the same as the one that you found that I haven't put there, if that makes sense. That was poorly worded, wasn't it? But I hope you understand what I mean. Now, it's always fun to take this a little bit further, so I am going to set you a little assignment to do just for your own fun. Think about C7H16, right? The isomers associated with heptane. And I'll tell you that there are 9 of them. So get hunting and then come back for the next movie.